Welcome to Standard Theory. In the previous segment we discussed the indirect dynamic of orthogonal thinking and shared communication. In this segment we will continue to explore intelligence on the R scale with absolute thinking and supersocial communication. In the previous segments we discussed characteristics 1 through 17. Each of those are somewhat closely related and follow a general pattern of increasing activation. Each of those thinking types have their own dynamic to account for the processing associated with those characteristics. In absolute thinking, though, the dynamic changes somewhat. Before, the characteristics were either experienced in a stepwise activation or the activation was shared indirectly between communicating parties. In absolute thinking, the amount of activation being processed actually exceeds the threshold of activation that the brain is able to handle at any given point. This leads to a problem when orienting the brain to the nature of the information as well as how to store and recall that information. As mentioned previously, each communication cycle should contain a discernible beginning, middle and end. Before, we were able to solve that problem based on the stepwise activation of each or the shared activation of each. In absolute thinking, though, there is a chance that all three, beginning, middle and end, are presented and on top of that are not discernible from one another. For this reason, the brain has to perform an additional sorting process prior to comparing the activations being considered. This additional process of sorting is one of the main features of absolute thinking. In addition, these sorting processes are referred to as nodes of communication and are comprised of a specific amount of cycle characteristics. In absolute thinking, those nodes are at 27, 54 and 117 cycle characteristics of communication. To begin with, we will consider the simplest form of absolute thinking in supersocial communication. We will refer to the process of composition which was discussed in a previous segment in order to address this. Using composition, we can consider the amounts of information that lead to the overactivation of the intelligent areas of the brain. This example refers to the process of constructive intimacy being interrupted by another person. In this sense, the characteristics being experienced by the three individuals would be noted as 6 plus 9 plus 9 plus 1, or as 6 plus 9 plus 10. This refers to one person who has maxed out their intelligent activation, one person who has become separated from their identity along with a second person who has become separated from their identity and, from there, the consideration of either of the parties on how to compose their own identity with respect to the communication cycle. This is a total of at least 3 identities being communicated at one time with a cycle characteristic of 25. This leads to too much information being processed as well as the beginning, middle and end of the process being unresolved in a way which leads to an incomplete cycle for each party. For this reason, an additional level of sorting is required prior to considering how to complete the communication. This is the simplest case of supersocial thinking and is referred to as three-party shared intimacy. As discussed previously, the options for solving this sorting problem can be considered using nodes of communication and sorted using one of two processes, either an intelligent, high-energy process or an impulsive, low-energy process. In supersocial communication, these sorting processes are referred to as directives and deferrals. This allows the information to be sorted in some way prior to completing the cycle of communication. A directive refers to an intelligent process while a deferral is related to an impulsive process. After applying one of those processes, the continued evaluation of those levels of psychological activations can continue. To begin with, the easiest way to truly resolve these problems is to reduce the amount of consideration being handled at once. So, for that reason, the default process could be considered to be a deferral of the additional identity. From there, another version of intelligent communication, whether shared, social, silent or intimate, can be used to solve the cycle of communication. This leads to one of the identities being considered as part of a different communication cycle. This allows the remaining 2 identities to be considered using a different type of communication while the deferral can either be resolved as no meaning or otherwise composed in a separate cycle of communication. The consideration of these identities only outside of three-party shared intimacy is referred to as the first step in supersocial communication. This first step of comparing 3 or more identities is referred to as the supersocial identity. The deferral of at least one of these identities can lead to moving to a different thinking type since the amount of information being compared can change. The other option, though, is to consider all 3 identities in a way that compares them using more information. This first directive increases the amount of psychological activation in a way that forces the brain to compare the magnitude of each of the 3 identities along with the perceived change in the identities or their influence on the overall comparison. This leads to the second step of supersocial activation. This second step of comparing 3 identities and the influence of those identities is referred to as a supersocial interaction. At this point, All three identities as well as their associated changes can be considered. The default action from there would be to defer at least one of those influences as different from the other two. That would lead to a change in activation back to the supersocial identity where the three identities can be re-evaluated and, subsequently, the identity with deferred interaction would also be deferred, resulting in a different communication type being used to solve that problem. The other option in supersocial interaction would be to compare each of the identities as well as each of the interactions by using more information. This would lead to the third step of supersocial communication, which is referred to as supersocial orientation. In a previous segment we discussed the overload event of horizontal thinking in intimate communication, specifically intimate orientation. That type of overload event is normally associated with neurotransmitter release. In supersocial communication and specifically supersocial orientation, a similar scenario is observed. Because of the capacity to store the information related to these processes, the brain experiences an overload event when trying to solve which part of the communication is which as well as where to store the associated information. According to standard theory, this overload event will lead to a physiological response. This physiological response is the result of this overload process and is regulated by the nervous system and likely the vagus nerve. This overload leads to the experience of a startle-like response referred to as eplexia. This startle response is related to survival and meant to conserve resources during times of threat or extreme stress. In theory, the amount of information being processed as well as the level of psychological activation required to achieve this exceeds the available amount of resource that the brain has at its disposal. This, as well as the absence of an additional neurotransmitter or other related chemical to mark and store the overload event, will lead to this physiological response. The standard theory of psychology refers to this process as gapping. This process of gapping has a few consequences. One consequence is the inability for the brain to access the additional resources needed in order to continue using intelligence and the processes related to intelligent activation. For this reason, the gap is crossed, the other versions of intelligence such as orthogonal thinking or horizontal thinking are no longer expressly accessible. Instead, the vagus nerve and nervous system does all that it can in order to conserve energy. This means reducing the brain's capacity to use up that energy in order to reallocate that energy for survival response. This leads to the phenomenon of post-intelligent processing. This type of phenomenon is not directly related to the R scale. In fact, the phenomenon is measured on its own scale, which is referred to as the Z scale. Previously, we mentioned the Z0 scale or scale of pre-intelligent impulse. We have discussed the entirety of the R scale or the scale of intelligence and can move forward to the Z scale or the scale of post-intelligent impulse. Please join me in the next segment where we will discuss the various aspects of the Z scale.